We're now on page 2 of Module 7, Lesson 6. I noticed that we couldn't tell the lines that they were talking about because they weren't in color, so I went ahead and put them in color, so you may want to do that too. So next we're going to look at perpendicular lines. We talked about these in Module 6 as well. So this is what perpendicular lines look like. They're lines that cross at right angles. So generally, to show the reader or who's ever looking that they are perpendicular, they'll put a little box there to show 90 degree. And I don't know how much you guys remember from geometry, but if this is 90, that has to be 90 because it's a straight line and straight lines equal 180. And if this is 90, then that has to be 90 because that's a straight line and all the way around. So one box is enough. That just lets you assume that they're all four because of the straight lines. But anyway, in order to be perpendicular, they do have to have that box there, or someone needs to tell you that they're perpendicular. Because how do we know whether that angle is 89.9 or 90? We can't tell that with the naked eye. So with perpendicular lines, there does have to be a box, or the directions need to tell you. So let's first look at the turquoise line. It looks like its y-intercept is about 0, 1. I agree with that. And it says its slope is rise 1, run 1. Yep, that looks right. Rise 1, run 1. Yep, that looks right. So y-intercept 0, 1, slope of 1. So if we were putting that into y equals mx plus b, you put the 1 in place of b, you put the 1 in place of m, and this is what it would look like, right? Because we generally don't write the 1 in place of x. Not that it's wrong, but we just don't usually write it. And then the purple line has a y-intercept, it looks like about 7. 1, 2, 3, 4, 5, 6, 7. Yes, that's 0, 7. And its slope is down 1 over 1, down 1 over 1. So it looks like negative 1 over 1, which simplifies to negative 1. So if we go into y equals mx plus b, and I do make you write the equation of lines from a graph, and this is exactly how you would do it on the test. You find the b, you fill it in or you find the y-intercept, you fill in the y-coordinate for b, you do count your slope, and you put that in for m. So there will be at least one, probably more problems on the test where you have to write the equation from a line on a graph. So this is what the equation would look like. In place of m, we plugged in negative 1. In place of b, we plugged in 7. So looking at the two equations, we can tell that they represent a pair of perpendicular lines because the slopes are opposites and reciprocals. So do you remember that from Module 6? We have it all underlined in Module 6, but it's been a while. So might be something you want to refresh your memory on. So opposites and reciprocals would be like 2/3 and negative 3/2, if you remember from Module 6. So not only are they reciprocals of each other, one has to be positive, one has to be negative. They can't both be negative, they can't both be positive. So that's why I put the word and there. So that means they have different signs. This means one is flipped over from the other one. So positive, negative, that's the opposites. 2/3, flip it over, 3/2. So just remember there's two characteristics that must be met in order for us to say that they are perpendicular. Different signs and reciprocals. So just to remind you, opposites mean different signs. So different signs and reciprocals. So I put some examples down here to show you other perpendicular line scenarios. So this one is positive 3 over 1. So its opposite and reciprocal would be negative, flip it, 1 over 3. This is positive 2/5, so its reciprocal would be negative 5 over 2. This fraction is negative 1 over 4, so its opposite would be positive, and its reciprocal would be 4 over 1. So you can see the sign changed, and we reciprocated it. So those would all be examples of perpendicular lines if we were to put them on a graph. Another characteristic, and most students don't take the time to do this, is if you multiply perpendicular lines, their slopes will always be, their product will always be negative 1. So let's take this example I wrote down here, 2/3 times negative 3 over 2. Multiplying straight across, I get negative 6 over positive 6, boom, negative 1. So that will always be true of perpendicular lines. When you multiply their slopes, you should always get negative 1. Okay, let's move on to page 3. So you've learned a lot already in 2 pages. You've learned parallel lines have the same slope, and because they never intersect, they have no solution. You learn that when 2 lines solve and they look exactly the same, one line will graph right on top of the other one. Those are called coinciding lines, and they have infinite solutions on that line. And then we learned about perpendicular. Just before we go on, how many solutions do perpendicular lines have? Solutions are points of intersection. Isn't there just one point? So anytime you have perpendicular lines, there's only going to be one solution. And you can name the solution, I don't know, 3, 1, 2, 3, 4, 3, 4. Let me see. If I put that in, 3, 4, if I put that, yep. So you're probably wondering, what did she do to get that? I just plugged it into the equation to see if it was true. When I plug 3 in for x, do I get 4 for y? 3 plus 1, yes. When I plug 3 in for x, do I get 4 for y? Negative 3 plus 7, yes. So that's how I verified that it was a point on both lines. So we weren't solving on this one, but I just want to point out, just keeping in practice with the first page. So parallel lines, no solution. Coinciding lines have infinite solutions. Perpendicular lines will only have one solution, and you name it by finding the point where they cross. So x was 3, and y was 1, 2, 3, 4. So that's how I got that point. So that wasn't part of the problem, but I just thought I would tie it into that first page. Okay, page 3. Consider the linear functions below. And remember, f of x, g of x, h of x, k of x, those all are just y. So don't let the function notation bug you. This is just y equals mx plus b, y equals mx plus b, y equals mx plus b, y equals mx. And because there's no number out there, I can assume b is 0. What do you notice about the equations of the lines given? So it looks like they have all different b's, so their y-intercepts are all different, but what do you notice about the slopes? All the equations have the same slope. Have the same slope. And what does that mean? Let's think about it before we go to graph them, because the graph will give it away. So if all of the equations have the same slope, all 4 of those lines are, boom, parallel. All 4 lines are parallel. From that first example, we saw that parallel lines on page 1 have the same slope. So I don't even have to graph it. I mean, it tells me to, so I'm going to, but I don't even have to graph it to know that. The minute I see their slopes are the same, I know when I go to put those on a graph, they will be parallel. So let's graph each one with a different color. So we'll do this first one with orange. So its y-intercept is 0, 3. And all three have the same rise over run. So let's write it over here. Rise over run is 1/3 on all three of them, right? M, 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 M. Rise over run, 1/3. So plot the point 0, 3. 1, 2, 3. Rise 1, run 1, 2, 3. Rise 1, run 1, 2, 3. Rise 1, run 1, 2, 3. Usually, if I'm giving you a paper pencil test, I would just make you do 3 points, but I was having fun counting, so I got a little carried away. So there is our first line in orange. Okay, next, try to scoot up a little bit so we don't run off the graph. Next, yep, we're going to run off the graph, so I guess I'm going to have to make it a little smaller. Dang. Dang, dang, dang. Okay, so next let's do a red line or a maroon line. Whoops, this one's losing juice. So 0, -3 would be the y-intercept. So I immediately go to the y-axis. Let's go ahead and label that since we didn't already. So 0, -3. And my rise over run's 1/3. So rise 1, run 1, 2, 3. Rise 1, run 1, 2, 3. Rise 1, run 1, 2, 3. So is that looking parallel as we predicted? It sure is. There we go, 2 down. Okay, next we have a green line. So its y-intercept is 0, -6. So go down to 0, -6. Plot your y-intercept. It also has a rise and run of 1/3. So rise 1, run 1, 2, 3. Rise 1, run 1, 2, 3. Graph the green line, and as predicted, because the slopes are the same, the lines are indeed parallel. And last but not least, what color do I have left? Ooh, gray, ugly gray. So good thing we put that 1 there so we knew what the y-intercept was. It's 0, 0. So if there's ever not a number there, you can add in the 1. So that means the y-intercept 0, 0, which means this line cuts right through the origin. It also has a slope of 1/3. So from that point, rise 1, run 1, 2, 3. Rise 1, run 1, 2, 3. And we are ready to connect. And there we go. As predicted, 4 very beautiful and colorful parallel lines. So let's answer these last 2 questions before the video ends. How are the lines geometrically related to each other? Well, geometrically, the 4 lines are parallel. And what can you conclude from that? If the slopes are the same, the lines are parallel. The lines are parallel. Copy fast, guys. The video's stopped.